This is an example of a precipitation reaction. We're going to write three types of equations for it: the molecular equation, the total ionic equation, and the net ionic equation. First, we have to recognize what we're given. This is sodium sulfate and barium nitrate, and we have to recognize those ions, the nitrate ion and barium and the sulfate ion and sodium. And the first step is to realize that in solution, if those compounds are dissolved, which they are because it says that they're aqueous, in the aqueous state, that means dissolved in water, and they're soluble substances. We know all sodium salts are soluble, and we know all nitrates are soluble. So we recognize that these are actually dissolved in water, and the ions are separate in solution. So we like to begin by writing the ions separately as the beginning of our total ionic equation. So here's the sodium sulfate written out. Sodium sulfate makes 2 sodium ions and 1 sulfate ion. Similarly, for barium nitrate, you get 1 barium ion and 2 nitrate ions. In this, we always work with the ions that we know. We don't create new ions or get creative with it at all. We use the ions that we've already learned. Once we know what ions we have in solution, we can imagine mixing these two things and thinking about what might happen. Could they form, now that the two substances are in the same solution, could they form some insoluble compound? Sodium salts are always soluble and nitrate salts are always soluble, so they're not really capable of forming insoluble substances. When we look at the remaining two, the barium and the sulfate, you might think that those are also, that's also can't make an insoluble substance until you look closer, because sulfate, although most sulfates are soluble, there are exceptions to that rule, and barium is one of the exceptions. We expect barium sulfate to be insoluble. So when these solutions are mixed, and sulfate from the sodium sulfate and barium from the barium nitrate can find each other, they can produce an insoluble substance, barium sulfate. So that's one of our products. Then we have to consider, by the way that's written now, it's written the two ions together because they're not individual ions in solution anymore. They've formed this compound barium sulfate, and it's a solid. It falls out of the beaker, out of the solution to the bottom of the beaker. That's our precipitate. And instead of saying aqueous in parentheses, we say S in parentheses for solid. Okay, so we no longer write them as separate ions, we no longer write charges on them, and we write them as being a solid. We have to consider what's left. There's still sodium ions and nitrate ions that haven't really done anything. You might imagine they're going to get together and make some compound sodium nitrate, but sodium nitrate would be a very soluble substance. And so they would still be loose ions in solution. So we just write them that way. 2 sodiums ions and 2 nitrate ions, aqueous, meaning they're dissolved in the liquid. Okay. So that actually completes our total ionic equation. It's the most complete representation of what's actually going on. The molecular equation above, notice sodium sulfate aqueous is written together, but we know because we've studied chemistry that actually that's a soluble substance, and that's why in the total ionic equation we wrote the ions separately. Similarly, for the barium nitrate, they're written in the molecular equation, the top equation, it's written as barium nitrate altogether, but the parentheses say aqueous. It is dissolved, and we know all nitrates are soluble, so really that is separate ions, barium ions and nitrate ions. Now we do the same thing on the other side of the equation. Now that we know the product, barium sulfate, but it is not aqueous, it is solid. So we write it the same way in our molecular equation, barium sulfate solid. The sodium and the nitrate, however, we write together in the molecular equation. They're written together, but with the parenthetical aqueous to show that they're actually that's actually a dissolved substance. And note that that's 2 sodium nitrates because we had 2 sodiums and 2 nitrates. So that then completes our molecular equation. The molecular equation is the one on the top. The total ionic equation is the one on the bottom. We have one more type of equation. It's called the net ionic equation. And what it does is it leaves out the ions in the total ionic equation that don't do anything. The sodium ions in the total ionic equation, they don't do anything, and neither do the nitrate ions. Those ions are called spectators because they don't do anything. They just watch, right? They don't actually do anything. In the net ionic equation, you simply leave those out. The result is barium ion plus sulfate ion forming barium sulfate solid. And that's what actually happened. That's the actual reaction that's occurred here. So those are the 3 types of equations. We have to know what they're called. We have to know the term spectator ions. And we have to know our ions to begin with in order to write any of these equations to begin with. But we'll leave it there. Thank you.